Welcome to Introduction to Mobile App Development, Module 4, Basics of Programming. In this module, we will start working in Visual Studio. We will begin by familiarizing you with the app solution and the various parts within the solution. Afterwards, we'll briefly introduce some basic programming concepts and then customize the default app behavior by adding some new code. Let's get started by taking a tour around the project that we opened in Visual Studio in the last module. When you work within Visual Studio, you will begin working with a solution. Most things you work on with Visual Studio will be contained within a solution. Typical apps or software products are comprised of a large number of elements. A solution provides an easy way to get all the pieces that are associated with the software that you're building. In terms of your App Studio app, your solution is called App Studio. It contains a number of different projects needed to build your app. Visual Studio will manage the parts of your solution and combine them into a finished app when it builds. In Visual Studio, you can explore the parts of your solution through the Solution Explorer. In the Solution Explorer, you can interact with the project in the same manner as you would if you were using the Windows File Explorer. You can drill into folders by expanding them with the caret, open files by double-clicking them, or perform other operations by right-clicking on them. A solution organizes its parts by grouping the various elements into folders and projects. Folders are identified with a manila folder icon, while projects will have an icon representing which language the project is written in. In the screenshot here, you can see that the AppStudio.Windows Phone is a project written in C#. You will also note that a solution can contain multiple projects, and that projects exported from App Studio will contain code for both Windows Phone and Windows. If you choose to generate for both Windows 8.1 and Windows Phone, which we are doing in this module. If you choose to only generate a Windows Phone 8 app, you will only find a single AppStudio.UI project instead. We'll focus on Windows Phone 8.1 apps, and we will primarily be concerned with the AppStudio.Windows Phone project. This project contains the user interface elements of the solution. In the project, you will find icons, images, and screenshots that are used to build your app's UI. You will also find all of the sections and pages you built in App Studio. Once you have begun editing your app in Visual Studio, you will not be able to go back into App Studio to make further changes. Any changes that you might have made in App Studio can be made in the AppStudio.Windows Phone project. Inside the AppStudio.Windows Phone project, you will find two key folders. The Assets folder, it contains all of your icons, images, and screenshots. If you add additional images or icons to your app, it is advised to keep them in this folder for consistency. In the Views folder, you will find XAML files that define the design of your section pages. If you double-click on one of the XAML files, it will open a page in a designer for you to edit visually. Next to each view is a tree expanding caret. If you use the caret to expand the view, you will see the code for the view. This corresponding code file is often referred to as a code behind file. We will be working with these files shortly. Now that we know our way around the app solution, let's take a look at running your app in Visual Studio, making some changes, and some rudimentary debugging with breakpoints. Thus far, we have worked exclusively with the design aspects of an App Studio app. We've defined sections, pages, and various components of your app. It is important to understand that each time you interact with one of these items in your app, that code will run. The code that powers your App Studio app is written in the C# programming language. The behavior for this example is to navigate to a browser to either the My Blog webpage or the University webpage. The code that runs with each UI element is easy to find if you understand how the project is organized. We will explain this shortly. Once you locate the code that handles the behavior of the UI item, you can alter the existing code or add new code to change the functionality of your app. We'll touch briefly on coding in Visual Studio and then try to make a minor change in the app's behavior. When we explored the Visual Studio project, you learned about the components that make up an App Studio app. In addition to the program code that runs the app, Your app also contains other resources or assets like images, icons, and data files. You may also recall that Windows Phone apps are written in the C# programming language. The code is comprised of a number of C# instructions that can direct the behavior of the app. These instructions direct the phone and how to handle the images and the data that it is working with. Let's take a deeper look into the app and see how this code works. Programming for Windows Phone apps is done in C#, which is a language that the Windows Phone operating system cannot read in the text form that we program it in. For the phone to run an app, the C# code must be turned into instructions that the phone can understand. The process for converting a high-level language like C# into binary code that the phone can understand is called compiling. In other words, once we have completed making our code changes in Visual Studio, they must be compiled into a new app that contains instructions the Windows Phone will understand. During this compile process, Visual Studio will perform checks to ensure that the code is written using a proper structure or syntax. If you make mistakes in your code, Visual Studio will abort the compile process and flag the problem lines in your code. For each section we created in App Studio, we can find a corresponding view and ViewModel in Visual Studio. This is because our App Studio app was built upon a design pattern known as the Model View ViewModel design, or MVVM pattern for short. If you wish to learn more about this, you can find more information in your extensions document or on the Microsoft MSDN site. Because of the MVVM pattern, we will find a corresponding view and ViewModel file for each section we created in App Studio. As mentioned earlier, the view files are located in the appstudio.windows phone project. The ViewModel files contain the code that is run when you interact with that code on your phone. If we alter the ViewModel code file, we change how our app behaves for that section. ViewModel files are named based on the section that they are associated with. The ViewModels folder is located in the appstudio.shared folder. This code file will be run whenever a user interacts with the My Useful Links section of your app. Let's take a closer look at this file. Once we've double-clicked on the file in the Solution Explorer, it will open in the Code Editor pane in Visual Studio. In the Code Editor, we can modify the code and change the functionality of your app. As you change the code in the editor, Visual Studio will attempt to assist you with some of its built-in tools like IntelliSense, but ultimately, it will be up to you to write the actual code. Once you start making changes to the program code, it is possible to introduce errors. The consequence of this is that the app will no longer compile and you will not be able to build the app until the problems are corrected. For this reason, it becomes prudent to keep a backup copy of your app. If you have made no changes to the app, it is always possible to retrieve a copy of the original code by downloading it again from App Studio. If you successfully make changes to the code and built a new version of your app, make a backup copy of the folder holding the appstudio.sln file or solution file. Programs in C# are made up of a sequence of statements. These statements are executed sequentially. Programming statements perform simple actions. As your program runs, these statements are executed in the order that they are entered in your code. As you develop your app, you might find it to be beneficial to see what is happening with your code on a line-by-line basis as it executes. To do this, you can use Visual Studio to set a breakpoint. Using breakpoints, you can begin stepping through the code one line at a time. As you do this, you can check to see what information is being held in variables, or which different lines of code are being executed. Okay, so let's explore using breakpoints in Visual Studio and learn how to do a little bit of debugging. As you've seen in previous demos in this course, you've learned how to download and open your App Studio app source code in Visual Studio. What you see I've done is I've drilled into the shared project here. In the shared project, there's a ViewModels folder. And the ViewModels folder holds a view model for each one of the sections that you've created. So we want to debug when the user clicks one of the links that'll bring them to an external website. So if you double click or select on the view model for your menu items page, you can see what this class holds. Now, class is one of the most important constructs of an application. It contains properties, and properties are the buckets that hold this information that is used in your application. A class can have methods and events, and it can do many different things. What we want to explore is the target URI property. So it's a local variable which will hold the property value of the website that we're going to go to. So let's put a breakpoint. You see how I clicked there in the left column? I can put another breakpoint there. I can put one there. This will stop the execution of the application. So what I want to do is put it right there, and then we're going to deploy to the emulator. Visual Studio will take the application, all the code, build it, and install it on the emulator. So the application is launched like we'd expect it to, but we wanted to hit the breakpoint, so we're going to come over to the useful links section. Now this section is using that ViewModel. I'm going to click on the official City of Venice site. What you'll see happen next is Visual Studio will come back into focus, and it will show you that there's a yellow highlight around the line of code and a yellow arrow in the column where you have the breakpoint. What we'll do next is come up here, or you can hit F10, and step over will break down one line. And let's do it one more time so you can see it happen again. So what we can do now is we can take a look at this conditional statement where it says if target URI is not null, let's go into this code block. So if I hit F10 again, you'll see that it goes inside. Now navigation services.navigate to will actually launch to whatever this target URI is. If I expand it by hovering over it, we can see all the values of the different properties of target URI. And you can see that we're going to go to www.commune.venezia.italy, etc. So to continue the operation of our app, you can click the continue button. So we'll see in the emulator it's going to navigate to the page, and it's obvious that there's something wrong with the website. But we did go into Internet Explorer. So if we click back, we'll go back into the application. Let's try a different website. Venice Connected. Step over. Okay, so the target URI is not null. It's going to navigate to it. We click continue and see if this web page works. And there we go. Just had a bad link. So that's a good way to test, to make sure the application's working. Now that we know there's something wrong with the website and not the app, that's crucial to what debugging actually does for you. So if we do go back to the app and I go to a different page, and let's say we go over to the museums and I click a museum, it doesn't hit that breakpoint. Why is that? If we open one of the photos, because it's in a different view. So the different view uses its own view model. Anything inside our view, my useful links view, will use the target UI there. But did you see that I did click an item and it did not hit the breakpoint? It's because it's not going to another website. It's going to another place inside the app. Okay, so let's stop debugging and take a closer look at that if statement.
Here is the code that we set our breakpoint on during the last demo. Let's break down this code and explain each part of it to fully understand how the Windows Phone is interpreting it. As a whole, these lines of codes are deciding whether something is true, and if it is, then it asks the service to take the user to a destination. In plain English, you might say it like this: if we have somewhere to go, let's go there. Let's break this apart into smaller pieces. This first line of code is something called an if statement. An if statement is a decision in the code. The phone will interpret a line like this: if a condition is true, then I'm going to do something. In this particular case, the if statement is checking to see if the condition contained inside the parentheses is true. If the statement inside the parentheses is true, then it will execute the statement contained inside the curly braces. In a real-life scenario, you would check to see if it is raining before you decide to bring an umbrella. Your internal logic in plain English would be, if it is raining, then I'm going to bring an umbrella. Now that we know what the first statement is, let's focus on the parts of the decision. Target URI on this line is a variable. A variable is a named piece of data. A wide variety of information can be contained in a variable, but in this case, we can expect the URL to be in this variable. This variable will be used on the next line of code to tell your phone app where to navigate to. An analogy for a variable might be a slip of a piece of paper with an address written on it. The slip of paper is the variable, as it could contain any information, but in this case holds an address. So the English to describe this would be, here is the address of the bar we're going to meet. Next, we are going to compare the information contained in our variable to something else. Typical comparisons you are probably familiar with are, is this value greater than that value? Is it less than? Is it equal to? The last comparison you might think of is whether or not a value is not equal to another. The exclamation point equals is the C# method for signifying is not equal to. Comparisons like these are represented with symbols like this, the less than sign or the greater than sign. These symbols are referred to as operators. For this example, is not equal to, you might express this type of comparison in English as, if your name is not John, then you can't come in. In C# and many other programming languages, there is a concept of nothing. Sometimes a variable will hold information, but sometimes there will be nothing in the variable at all. It's not zero, but no value at all. The keyword null is used to represent this situation. If the target URI variable has never had any value stored in it, or if it contains an invalid value such as numbers when there should be characters, then target URI will be null. You might say, only people with a middle name are eligible. Now let's evaluate the entire statement based on what we've learned. In this case, you know we are checking something with our if statement and checking the value of a variable for a null value. An if statement will perform the extra code statements if the comparison equals true. So in this case, if the target URI variable does not contain a null value, then the additional code will be run. If the target URI has any other value other than null, no additional code will run. This type of comparison is called a logical operation. These are the heart of logic in all software. If the condition has been evaluated to true, the program will proceed to run all of the lines of code contained inside the curly braces. The next line to run in this case is a call to something called navigation services. Navigation services can perform a number of different types of operations. One of these operations is navigate to. If you give navigate to a URL, it will navigate your app to that URL. In this case, we know that target URI must have some type of information in it because it passed the if statement. So the navigation services will try to use that information in the target URI as a place to navigate to. With a basic understanding of these lines of code, we can now make a small modification to our app's code. We can add additional statements or change what the commands do to add more features to our program. These same techniques can be used throughout your app. Let's go ahead and try some of this. Okay, now let's examine how we can put some code inside the if target URI is not null and output something to the Visual Studio Debugger's output window. So let's come in here. We know for a fact that target URI will not be null. There will be something inside that variable that we could use. So let's do this. We do system.diagnostics.debug right line. And make sure that's capital. So the way this works is Visual Studio will pass this information to the debugger. So we're going to put target URI in there. Remember to close off the sentence with a semicolon. It's just like a period in English. Alright, so now with no breakpoints, we'll still be able to see what's going on. So we click the emulator. We're going to deploy. And let's do the same thing we did before for the breakpoint. So we're going to come over to my useful links. I'm going to click my useful links and go back. See down here in the bottom left how it showed the website that we're going to? So even though that we know that site is broken, it still outputted the value. So now let's come to the working site, and then it's not connected. So that's how you can use the debug write line to help you see what's going on in your application without actually having to stop the workflow. This is really useful when you're trying to track down a bug that you really can't get at easily. So you can put them in your view model, you can put them in the code behind for your views. You can use it anywhere that there's C#, and whatever you pass into it will be outputted to the window. So we could even do this. So what this does, it adds a little bit of text to the end so it can help you keep track. So if you have a bunch of debug.write line statements all through your app, you might not know exactly what it's doing. So a little good tip would be to add a little something extra to that statement that will tell you what's going on. So if we click the working one, and there you go. You can see is the site we're trying to go to.
Here's a walkthrough again of what you just saw. This is our original code. The if statement determined if a URL is in the target URI variable. If the variable is not empty, then the navigation service is used to open the URL. We just worked with the same code segment and added a new line. This new line used the debug object to write a line of output to the debug output pane in Visual Studio. Now, with the new code, the if statement will determine if a URL is available in the target URI variable. It then proceeds to run the next two lines of code inside the curly braces. The first line of our new code that uses the debug output pane to show the URL that was being used in the navigate to call. The next line causes the navigation to the URL. Remember that a debug message is displayed only in the Visual Studio debug output pane, and it is never visible to the user of the app. This technique is very useful for tracking the progress throughout your app without changing its functionality. In this module, you got your first chance to make code changes to an App Studio app. You learned to find your way around the app solution and where some important pieces of the app are located in the solution. You also learned that an App Studio app is based on the MVVM pattern and how the app sections are stored in the view files and are controlled by the ViewModel code files. You learned how you could interpret a conditional statement called an if statement and how to add extra code statements to your app. In this lab, you will have a chance to practice some of the things you've just learned. First, you will see how to use Visual Studio tools to modify the splash screen of your app. Then you will use the techniques from this module to add code to your app.